Okay, guys, so today we're just going to solve a few more log problems. We're not going to use a calculator for any of these, so for some of the questions you can leave a log in your answer. Okay, so let's start by looking at number one. So for number one, a really common mistake I've seen is for kids to say ln of the left side equals ln of the right side, which that part's correct. Then they move the 2x in front. The problem with doing that, that's not correct. The problem with doing that is that the 2x is not the exponent for the entire value here. It's only the exponent for the e. So you couldn't put the 2x in front in that case. So what you have to do is instead of that, you have to first isolate the term with the exponent. So we'll start by dividing both sides by 8. Now to get the log out of, or to get the variable out of the exponent, we'll take the ln of both sides. So we have 2x times ln e equals ln of 28. Now ln e, that's the number 1. Let's think about it. Ln is log base e, and that's equal to some number. So e with what exponent equals e? It's just 1. So really we just have 2x equals ln 20 over 8. So it's really just x is ln 20 over 8 all divided by 2. All right, let's look down at 3. So for 3, we can try to solve this question by factoring. So we want to write two terms that multiply to give us e to the 2x. Remember that when you multiply with the same base, you just add the exponents. So we're going to put e to the x and e to the x. Our second two terms have to multiply to give us negative 2. So we're going to try a positive 1 and a negative 2. Now, when we solve the first part, we know that two terms multiply to give us 0. So either the first term is 0 or the second term is 0. Okay, so if we solve this, we get e to the x equals negative 1. But 2.7, or a number close to 2.7, with an exponent cannot be negative, so there's no solution here. Over here, we have e to the x equals 2. To solve, we're going to take the ln of both sides, so we get x multiplied by ln e is equal to ln 2. Well, ln e is just the number 1, so we really just know that x is equal to ln 2. All right, let's flip over and look at question 7. So for question 7, what we want to remember is whenever we want to solve an equation where there are exponents on both sides, something we could try is to rewrite both sides with the same base. So on the left side, we have 2 to the 3 over log base 5 of x. And let's rewrite the other side as 2 with an exponent. So 1 over 16 is 2 to the negative 4. If these two sides are equal, the exponents must be equal. So we have 3 over log base 5 of x equals negative 4. Now to solve, we're going to cross multiply. Negative 4 times log base 5 of x equals 3. So then log base 5 of x equals negative 3/4. So x is 5 to the negative 3/4. Okay, so now let's go over question 11. For question 11, remember that when you have logs in the exponent, you can put them, that when you have an exponent, a log with an exponent, you can put the exponent in front and multiply by it. Now, there's more than one way to approach question 11. You may look at it and say, I just don't know what to do, but try to rewrite it some way and then just see what you can come up with from there. Okay, so once we get down to here, a good technique when you're multiplying is to just remember that change of base formula that we learned and to rewrite everything with the new bases. Okay, to make it easier, because I see I have log 8 and log 3 over here, I'm going to rewrite 64 as 8 squared, and I'm going to rewrite 9 as 3 squared. Okay, now our goal is to get x by itself. So we want to cancel out multiplying by this fraction that's next to it. To cancel out multiplying by a fraction, you divide by it, which is the same as multiplying by its reciprocal. So on both sides, we're going to multiply by log 3 over log 8, and I'll write that. Okay, so on the right-hand side, we really have 2 log 8 over 2 log 3, and we're timesing it by log 3 over log 8, which we got from the left-hand side. So now we can cancel a bunch of things, and on the right-hand side, we're left with 1. So we have log x over log 6 equals 1, which means log x equals log 6, so x is just the number 6. Okay, so we can do a graphing one now. Let's flip over and let's look at harder one, 16. So whenever you're asked to graph a log, what I would do is I would solve for the inverse, which is always going to be an exponential function. It'll be something like 1/3 to the x. I think it's a lot easier to graph the inverse and to then reflect that over the line y equals x. So for the inverse, we have x equals negative log base 1/3 of negative y. So then we could divide by negative 1 on both sides. And then we could say 1/3 to the negative x equals negative y, which is the same as saying 3 equals negative y. I'm sorry, 3 to the x. Because the negative sign in the exponent means take the reciprocal. Okay, now we're going to divide by negative 1, but remember that the negative 1 is not raised to the x. All of our y values are going to be negative here. So when we graph this, we get that we have a dot at 0, negative 1. And then when the x's get really big, the y's are just going to get small. If you put in a number like 100, you're going to have negative 1 times 3 to the 100. It's going to be really tiny. When x gets small, y's are going to get closer to 0. So that's the graph of our inverse. To get the graph of the original of the log, we want to flip all these points over the line y equals x. If it's confusing for you to do that, you can also think of specific points. You can say, okay, I know that 0, negative 1 is a point on my original. That means negative 1, 0, the flip of it, the reciprocal. Or, I'm sorry, to get the inverse function, you just switch the x and y. So instead of negative 1, 0, we have, instead of 0, negative 1, we have negative 1, 0. You can come up with other points. So on this graph, we would have the point like 1, negative 3. So that means on the inverse, you're going to have negative 3, 1. So if we draw this out like that, you're going to end up like that, and then like that.